ladies and gentlemen.
The other special right triangle we're going to talk about is the 45, 45, 90 triangle. So where this triangle comes from is we have a square, and this square has side lengths of 1 unit. So it has a height of 1 unit and its base is 1 unit. What would the diagonal of this square be? So a diagonal, for all intents and purposes, is when we connect one corner to its opposite corner on a shape. So how long would this diagonal be? Well, if we cut the square like this, we actually end up with a right triangle. And that right triangle looks like this. Well, we can use Pythagorean theorem in order to figure out how long it would be for a unit square. Then we can scale it to meet any one of our needs that we have. So for a unit square, we would have 1 squared plus 1 squared is equal to our hypotenuse, which is the diagonal, which would be question mark squared. 1 squared is 1. 1 squared is 1. So 1 plus 1 is 2. So our question mark squared is equal to 2. How do you undo a square? With a square root. And that means our question mark is equal to the square root of 2. Scaling this, that means whatever 1 is, if we just make that into an x, the other leg would also be an x. That means the hypotenuse would be x times the square root of 2. And we can use that in order to help us solve some problems as well that involve special right triangles. Again, these triangles, 2 angles are 45 and 1 angle is 90. It's also known as an isosceles right triangle. So let's try a problem. So first question, what is the length of the hypotenuse of a 45, 45, 90 triangle with the legs with length 4? So we can use what we know about the proportions to say that this is going to be root 2 times bigger than 4, which means it's going to be 4 square root of 2. Or we could use Pythagorean theorem in this case because we know it's isosceles. This would be a 4 as well. 4 squared plus 4 squared would equal x squared. 4 squared is 16, so 16 plus 16 is equal to x squared. 16 plus 16 is 32, is equal to x squared, so x is equal to the square root of 32. Mr. Willie, those don't look the same. Contraire. 32 is 16 times 2, and 16 is a square. The square root of 16 is 4, so that is how we get the 4 square root of 2 from this. It is just the simplified version of whatever number we get from the square root. So that is how it works. Let's try an application. So we want to find the diagonal of a square with a perimeter of 40 square root of 2. So if the perimeter is 40 square root of 2, that means if the side length is x, then we have 4x is equal to the perimeter, which is 40 square root of 2, meaning that x is going to be equal to 10 square root of 2. So now we know that the side lengths are 10 square root of 2, 10 square root of 2, and we want to find the length of the diagonal, which is essentially a 45, 45, 90 triangle, which means that the hypotenuse is going to be root 2 times larger. So 10 root 2 times root 2. Well, the square root of 2 times the square root of 2, what number is the square root of 2 squared? Well, the square root and the square cancel. That leaves us with 2. So 10 times 2, that is 20. If you need a little bit more connection there, the square root of 2 times the square root of 2 is also just the square root of 4, and the square root of 4 is 2. So if it didn't make sense the square and the square root cancel, maybe that will. That is it for this one though. So your ratio here for all of these triangles are going to be 1, 1, square root of 2, or x, x, x square root of 2 times the square root of 2. So whichever way you remember it, I like to do 1, 1, square root of 2, the largest numbers in the square root, so that way it stays in common with the 30, 60, 90 triangles, which were 1, 2, square root of 3. So you have a little bit of commonality there. If If you have any questions about this, please let me know. Otherwise, I look forward to seeing you in the next video.